This is the pre-video for section 2.3. Coming up on Monday, we will have a worksheet that will provide some questions, one from this pre-video and one that's similar, to see if you have been keeping up with your pre-videos. So make sure you're always watching these. Of course, you wouldn't know that I said that unless you're watching it, right? So quadratic equations are equations that are raised to the second power as their highest exponent. So a lot of times these look like trinomials, things that we've seen before, like ax squared plus bx plus c. They don't have to have all three terms, but they have to have the x squared part, or it's not a quadratic. So there's an example of what a quadratic can look like. There are 4 ways to solve quadratic equations. This video is only going to focus on number 1, just a factoring review. Since we've already covered factoring once in this class. So to do factoring, you have to get the equation in standard form, which means you have it equal to 0. So right here, this is standard form. And then we factor it if possible, and then use what's called the zero factor theorem. The zero factor theorem says that if two things are multiplied together, and one of them, and it's set equal to 0, then either A is 0 or B is 0. Those are our two options. Ways 2, 3, and 4 are going to be covered in class on Monday. So here is our zero factor theorem. We just kind of talked about that. And this is, like I said, the method of factoring is the way we're solving here. If a factor ever appears twice, so say you factor something out and you get something like this, set equal to 0. We would say that x plus 1 occurs twice or is a root of multiplicity 2. If it had a third power, we would say it's got a multiplicity of 3. Just means that the answer appears more than once when factoring. Okay, so let's jump right in. So notice my first one has some pretty big numbers, but I should always check to see if I can pull out a GCF first. So let's check and see if 72 is divisible by 4. It is. And 324 should also be divisible by 4. And it is. So we can pull a 4 out first. That makes things a lot easier. This was an 18x, and I believe the last one was an 81, equal to 0. Okay, then that trinomial factors, 81 factors that are going to multiply to positive 81, but add to negative 18 would be negative 9 and negative 9. So notice right away, this is a multiplicity of 2. So if we wrote this, this would look like this. And this piece, since it shows up twice, you only need to solve it once. We set it equal to 0, so x equals 9. Some people write 4 equals 0, but that doesn't really make sense. If there's no x out front, there's no solution from that piece. So this is x equal 9 with a multiplicity of 2. Okay, so let's look at this next one. A lot of people want to try to set these equal to 27, but the rule is it has to be set equal to 0 to use the property. So we actually have to undo the work here by distributing, and I'm going to go ahead and subtract the 27 over. This time I did not get lucky. There is not a GCF that I can pull out of all of those. So I'm going to have to do 8 times negative 27 and do the factor by grouping method. Sometimes it just, you can't get away from it. It's going to be negative 216. And we need factors of 216. So 1 and 216, 2 and 108. Let's see if 3 goes into it. 72. Does 4 go into it? I have a feeling this one's going to have a lot of factors. 4 and 54. And 5 won't go into it because it doesn't end in a 5 or a 0, but does 6 go into it? 6 and 36. And I'm actually going to stop here because I know there's more factors, but this is negative 216 and we need it to add to 30. So if we have a negative 6 and a positive 36, that will multiply to this but add to the middle. Once you find your pair, remember you have to change this to a 4-term problem so that you can factor by grouping. I can pull a 2x out of the first pair. That leaves me with 4x minus 3. I can pull out a positive 9 out of the second pair. That leaves me with 4x minus 3. So then that would become 4x minus 3 and 2x plus 9 equals 0. We set each part equal to 0 by the zero factor theorem. We solve by adding and subtracting as necessary and dividing. So I get 3/4 is one possible solution and negative 9/2. Okay. Then we come up to my last one. This is the last one for the pre-video, and I'm actually going to make sure I add in some extra space, running a little thin on space. This one's a little bit of a problem because we have a rational equation, which means you could have issues with your answers. First thing to do is to always go ahead and factor all the denominators to see what your x's can not be. And my x can't be either a positive 2 or a negative 2 because those would create zeros in those denominators. But my LCD is x plus 2, x minus 2. Now, we learned last time that you can clear these out. If you've done that enough, hopefully practicing in your homework, what you notice is that if you just multiply everything by these two factors, as you go, you just get the numerator times the part that wasn't in the denominator. So essentially, this first one is 3x and an x plus 2, because the x minus 2's would cancel out, plus a 1, because that's my next numerator, and this x plus 2 would cancel out, so we'd still have x minus 2 equals, go ahead and put that negative with the top, so negative 4, and all of the denominator would cancel out because it's the exact LCD. So then I will distribute. Need to get everything on one side and combine like terms. Do not try to factor by grouping in this method. Obviously it's going to work because, well, no, it won't work because the signs won't match, but it's not going to help you if you're not combined everything yet. So then we'd add the 4 over, so this would be plus 2. So again, this is factor by grouping method. 3 times positive 2 is 6. Factors of 6 that give us 7 are 1 and 6. So we can put 6x plus 1x plus 2 equals 0. Pull out a 3x, get an x plus 2. Pull out a positive 1 because you have to pull something out. You get an x plus 2. So we get x plus 2 and 3x plus 1 equals 0. Solve them, we get x equals negative 2. If you solve 3x plus 1, you get negative 1/3. Now, only one of these is a solution because remember what I pointed out at the very beginning? X could not be negative 2 or positive 2 because of all these denominators, okay? So the problem is that is not a valid solution. So the only solution, even though we solved everything and got 2 solutions, the only valid one is negative 1/3. Okay, that's the end of the pre-video.